Okay, this is Pure Free, Jan 21. This paper's done very differently, whereas the answers have been done first and we've spoke for it because a lot of my students' exams are tomorrow, so it's just a quick video. However, we were stuck on one question as to some of the reasoning, so if anyone wants to help out, feel free. Good luck, everyone. Okay, and this one, nice and easy. First one, index form. And we're finding the integral. Then we have to remember we've got x to the minus 1. We cannot integrate x to the minus 1, and this should give you a clear sign. If you add 1 and you get 0, I want you to think la 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 lin. Okay? If you add 1 and you get 0, lin. Okay? Because it's not right for some of you that just put 0 here. Okay, so you have to remember that a half x to the minus 1. Now, some of you did think ln. However, 1 over 2x you said was ln 2x. Why is that wrong? Yeah, you guys are so right. If we integrate this, it's not going to give ln of 2x because let's assume ln of 2x is our y. If we differentiate this, dy by dx, what do we get? We get 1 over 2x, and then we multiply by the differential of the bracket. Differential of 2x is 2. So that equals 2 over 2x, and these cancel and I get 1 over x. Remember, it's because it's a constant, essentially, isn't it? Because this is the same. Remember, ln of 2x is the same as ln of 2 plus ln of x.
So isn't that right as well?
No, of course it's not right.
Why?
So, because 2 over 2x is 1 over x.
Yeah, but that's just a simplification.
Okay, we have a half lots of this. So, of course, using our assumption, we would then need to divide by 2, which is where we get the half from here. You've got to remember, it's very different with our constants. And then x to the 3, increase the power by 1, negative 2, minus 5 over 2 divided by minus 2 is plus 5 over 4. I've been assured this. Is this true?
Okay, minus 4.
Is this true?
Power 2 divided by 2 power 4.
Perfect. And then our constant of integration plus c. Okay, if you're still struggling with this concept, please look at my other YouTube video, which has lns.
Why does this?
Absolutely. So another way is 1 over 2x can be written as a half times 1 over x. Yeah? If we integrate this, we don't integrate the constant. The constant is the half, isn't it? We integrate the 1 over x, because that's attached to it. It's just like if we integrate 2x. We don't integrate the 2, we integrate the x squared. Yes, but we've just proven that ln of 2x
Doesn't really make sense.
well, now how does it not make sense? Wait there. Right. First of all, yeah, this answer is completely correct. The red part.
Mathematically, it's correct.
Which mathematically is correct.
Yeah,
Of course it's mathematically correct.
So why does it not work? Because
No, I've proven here why it doesn't work.
you just divided the 2 by. Okay.
Right, so let's forget we're integrating. We're differentiating now. Y equals ln of 2x. If we differentiate that, we get 1 over 2x times the differential of the bracket, which is 2. So I get 2 over 2x, which is in fact 1 over x, yeah?
Yeah.
So how can I integrate 1 over 2x to get ln of 2x when I you're saying if I integrate, this is my answer. Integrate. So therefore, you're saying that if we differentiate ln of 2x, we should get 1 over 2x.
No, that's why you do ln of 2x over 2 to get 1 over 2x.
Ln of 2x over 2. Yes, that would give us 1 over 2x. However, we wouldn't write ln of 2x over 2.
Why? That's the correct integral using assumption.
Ln of 2x, and then you're dividing it by 2.
You get divided by 2, you multiply.
No, I
So
think
that'll be 4x. No, because they.
we can't integrate Lns in pure free. So this is what we have right now.
No, I'm assuming.
What are you assuming?
I'm assuming that the integral of 1 over 2x is ln 2x over 2.
So ln 2x a half. So you want to assume this.
Differentiate this.
Right, let's differentiate this. So we're going to get a half times 1 over 2x times 2.
Yeah.
Okay? Is 1 over 2x.
Oh, that works. That's what I usually do.
I see where you're going with that.
Oh, you just, okay, so you just knew it was divided by 2, so you just did it straight off.
That's, yeah, using assumption.
However,
Would that make it correct?
I see what you're saying. However, using our assumption. However, do you remember when we first started doing this chapter, do you remember when we said if this was a ln of 4x, it just differentiates to 1 over x?
Yeah.
We technically wouldn't say it differentiates to 1 over 4x, then times it by 4.
If it was divided by 4, it would be 1 over 4x.
I don't know, I'm a little bit confused on that one. I think you've confused me. Okay, if someone out there can explain this, I've confused myself, but I'm still going to upload this video. Someone just explain this to me. What have I gone wrong and done? Okay, question 2. Oh, this one was easy. So we have 3 coordinates. Now it's really important you know that this is 0, 0. They might not have written it. Right, this is inside the bracket, so we do the opposite to all of our x coordinates. We divide them by 2. This is outside the bracket, so we multiply all these by 3. And then here we have our graph, and all I've done to these is a half divided by 1 divided by 2 is a half, 2 times 3 is 6, blah, blah, blah. Same with this one. We divide all of our x coordinates by 1 because it's inside the bracket. That is actually a reflection in this y-axis. And then we have to minus 1 from all of the y coordinates because it's a shift down, okay? Use a ruler and a pencil. Okay, question 3. Now this one had a lot of people confused. I haven't done the whole thing here because I realised it's going to take me a long time. Well, not really a long time, but a lot of people got this wrong because of something. So everyone knows BIDMAS, right? Okay, well, first things first, okay? Ooh. Right, let's just look at this. So, BIDMAS looks like this, and everyone always thinks it's addition before subtraction. But it's not. Your A and your S, you read left to right. When you just have addition and subtraction, you read left to right. It's not addition first. For example, 5 minus 2 plus 3. Okay? And I'm going to write it here, 5 minus 2 plus 3. If we did addition first, before the subtraction, on this, we would get 5 plus 2, which is 5. And then we'd get 5 minus 5. What do we get? 0. However, on this one, if we read left to right, 5 minus 2 is 3. Plus 3 is 6. Can you see they're not the same? They're completely different, aren't they? I know what you're thinking. Mind blown, right? This is
Minus 2 plus 3 is obviously obviously 1. How do you get that minus 5?
what's 5 minus 2?
5 minus 2, that's 3.
Yeah. And then plus 3, because that's what's left.
You did 2, minus 2.
No, what I'm saying is I did the addition first. I did this part first. It's like I put in an imaginary bracket. That's what a lot of people did. They added this one to this one and then did 3 minus the whole thing. What I'm saying is that's wrong. We need to put them all over the same denominator and then expand everything and go from left to right. So another way, you can do this first and then add that on. Okay, once you do all that, you should get 4x plus 1 over 2x minus 5. So that was really simple, okay? And then part B asked you, I didn't even finish this question, sorry. This is A, that's C. Okay, part B just asked you to do it. So y, 2xy minus 5 y equals 4x plus 1. So 2yx minus 4x equals 1 plus 5y. X bracket 2y minus 4. Okay, I've just done this really quick, 2y minus 4. Okay, so everyone should be happy with how we do this anyway. This was GCSE level, right? 2x minus 4, brilliant. So this is just functions, rearranging, and that's the answer. So that was a nice easy 2 marks. Then it says, hence find the domain of f inverse. So I want the domain of this. Now, remember, the domain of this is the range of the first one. Everyone happy with that? So it's easier to figure out the range of this one. Now, whenever we have a fraction like this, we know it's 4x plus 1 minus 5, okay? So the answer is 2 is less than x is less than 17 over 3. How did we get that? Well, first of all, how did I get 17 over 3? A lot of people got that. They substituted x equals 4, okay? Because this will then give us, if x has to be greater than 4, when I substitute 4 into this, this will give us a value, yeah? Okay, so 17 over 3, I've got that. So I've written 17 over 3, but I have no idea yet if it's greater than, less than, equal. I don't know. I've just left it at this. Okay, I just know when I substitute in x equals 4, that's what I get. Now, with fractions, it's really funny because whenever you plot a fraction, you have to know this, that there will be an asymptote. Because it's a fraction, it's never going to get to 0, is it? Okay, and it's also never going to go to infinity. So what we do is whenever we have anything like this, I always, if they ever give us like a boundary here, they've given us 4. Okay, I now substitute in something like 1,000 or 10,000 and see what it gives me. So if you put in 1,000 into 4x plus 1 over 2x minus 5, so 4 lots of 1,000 plus 1 over 2 lots of 1,000 minus 5, if you put in 1,000, it would be 2.000, something like that. Or put in 10,000. You know, I just think of a really big number. I know that's not really that big, but you know, sometimes I start off with 100 and then I put in 1,000. And what you'll find is when you keep putting them in, it's tending towards 2, isn't it? Yeah? So then we're saying, as x tends towards infinity, y tends towards 2. Now, if you think, if you've got 2 and 17 over 3, which one's bigger? 17 over 3. So I know that 2 is less than x is less than 17 over 3, because that essentially is my range for my f of x, which becomes the domain of my inverse function. Okay? Yeah, sorry, but the answer, yeah, but this is for my y, which now becomes my, yeah? So, a really good question. Someone said, but do you know what? 2x minus 5, it can't be 2.5. That's right, we're saying x can't be 2.5, but it doesn't matter. X cannot be 2.5. It doesn't matter for this question. Why? Because it's already told us x has to be greater than 4. So this is then counteracted, but this is a really good question. Okay? If they hadn't put anything here, you can now put x cannot equal 2.5, because obviously we cannot divide by 0. Yeah? But because they stipulated x has to be greater than 4, 4 is greater than 2.5, so we don't have to worry about that. Okay, question 4. This one was nice and easy. So, find in terms of A the coordinates of P. So we know that opposite this is going to be essentially our minimum point, isn't it? So 3x plus A equals 0. Yeah? And then what is x? Negative A over 3. And then we have A. Okay? Yeah? Then, part B. So sketch the graph of the equation y equals g of x, where x plus 5a is in the modulus. So, x plus 5a. What do we know? That means that our graph, that normally looks like this, has been moved. Oh, has been moved. Is it inside or outside the bracket? Inside. What do we do? Take away 5a, so it's been moved there. If we take away 5a, we've then got minus 5a, 0. It then says, how do we know where it crosses here? Well, we just substitute 0 to see where it crosses the y-axis, and then we're left with 5a. So there's the next one. Then, part C, it says they intersect the graph. Now, quite a few people got this wrong. However, I understand why. So, first of all, the left-hand side of the equation, 3x plus a, this equals x plus 5a. And then the second equation is minus 3x minus a, because we do the opposite of the modulus, right? We multiply it all by minus 1, plus a equals x plus 5a. Now, you notice x plus 5a stays the same for both. Why is that? And I'll show you why now. It's because this, whenever we're solving this, we're saying, where does this? We always do the normal and then we multiply everything by minus 1, right? But this one we're not going to multiply by minus 1. If I was to draw this graph on top of this graph, okay, there's only two solutions, and the two solutions only cross on the positive side. They cross when that is positive. So x plus 5a and x plus 5a, they have to stay positive because it crosses on this side of the positiveness. Does that make sense? It really made more sense in my head, but yeah, perfect. And then obviously once you got your value for x, you substitute in for y because it wants coordinates of 2 points. Okay? Perfect. Okay, so question 5. Again, pause it, read through the question. So we know that 18 is the outside temperature. We can put 18 here. We know this is the initial temperature when it's 0. And it's really straightforward. This is 2 marks, probably the easiest 2 marks in there. We've seen integration questions for 2 marks later on down the line, which are a lot harder. You know that this is going to be 1, and then just rearrange. You get 198. This is now your initial value, A. It then wants you to do 5 minutes, and it's 90 degrees. So literally, we substitute everything we know. We know the answer is 90 degrees. We know that is when the time is 5 minutes. Rearrange it, learn both sides, and then we get k equals minus 1 over 5, ln to the 3 over 5. Now, just to say, in the mark scheme, they also accepted 1 over 5 ln to the 5 over 3. Because what they've done is they put that negative as a power up here, to the negative 1, so obviously that's a reciprocal, isn't it? Yeah. Then for part C, it says the temperature inside the oven 9 minutes after the oven is switched on. Give your answer to 3 significant figures. So we just substituted 9, and we end up with 126 degrees. Okay? Then B, it says the rate of increase. If we're ever finding the rate, we have to differentiate. Rate, differentiate. Yeah? Did you get it? Yeah. So when we differentiate this, we obviously have negative 180e to, and this is what we worked out was our k, right, to the minus k. However, remember that ours is a negative, so that's why it's now a positive, yeah? To the power times t. Remember, t essentially here is our x. So when we differentiate an e, we keep it the same, and then we multiply by the differential of the bracket. This is my bracket, isn't it? And this 1 over 5 ln, 3 over 5, this is just a number. So this times t, we're just left with this. Imagine, and this is why I put here, e to the 2x differentiates to e to the 2x times 2, does it not? Yeah? Okay? Don't worry about that. That's very confusing. Okay then, so once you've done that, you then, once you have this, you now substitute your value of 9, because you want to find the rate when it is 9, and then to 3 significant figures, 7.33. Nice and simple. Okay, question 6. So this one was, it was fairly simple. We just had to make sure we did everything right. Okay, so the first bit was to differentiate. So we have 2 functions, v and u, yeah? v du plus u dv. So what is my v is x? Okay, so here's my x. And then the differential of cos x over 3, remember, sine, cos, minus cos. It differentiates to minus sine. Okay, so that's how we have the minus sine x over 3. And then remember, we also have to multiply by the differential of the bracket. The differential of x over 3 is a third. So that's how we get this side. Plus u, which is cos of x over 3, multiplied by dv. Differential of v of x is 1. So that's what we get. So this equals 0. So that was nice and easy for 2 marks.
It then says show that f dash of x equals 0 can be written as x equals k arctan k over x. So I need to get rid of this minus. I moved the sign onto the other side, okay, to get rid of the minus. Moved that onto here. I then divided both sides by cos, okay, and then multiplied both sides by 3 and divided by x, if that made sense. Like, I put that here and that here, like straight division. So I got 3 over x and sine over cos, okay? Now, sine over cos equals tan. So I get 3 over x equals tan. Remember, arctan is just tan to the minus 1. Yeah, you know, like when we do like SOHCAHTOA, we're trying to find the angle. Yeah, so arctan of this side equals x over 3, and then I multiplied both sides by 3 to get x, which is proved. Nice and simple. Then all I had to do was put it into my calculator. Now, some people didn't get the correct answer, and it's because unless they tell us, always have your calculator in radians. Unless it says degrees, we need to use it in radians. Radians is how we use it practically. Degrees is more when we're working with shapes. Okay, you know, like triangles and all of this. So ideally, you want to be in radians. So some people were getting this wrong because they were in degrees. So then we're able to find the root, okay? And last part of the question, we just substitute and press equals equals, you know, just like normal. Then part D, it says use in a suitable interval and a suitable function. Okay, it's really important. You remember numerical methods. We need to change sign and we need it to be continuous. Arctan is not continuous, but sine plus cos is continuous, so you have to substitute it into this one. Remember to use your upper and lower bounds, okay? For 3 decimal places this is. So upper and lower bounds, and substitute it into the sine and cos. Remember, because for it to show this, it has to have a change of sign and continuous. It's really important that we remember those two things, okay? Yeah, it also specifies in the question to use the derivative. So we are going to use that one. However, we've shown that the derivative can also be written in this way. But we're not going to use arctan to substitute our value in because arctan is not a continuous function. Okay? Right, question 7. We've got 3 marks to prove that this equals cosec. So I multiplied both sides by... No, I didn't. I changed first sine of 2x into 2 sine cos x and cos of 2x into 1 minus 2 sine squared x. I then multiplied this one by sine over sine and this one by cos over cos to get this. Then these two cancelled, so I was left with cos x over cos x sine x. I don't know why there's an extra x there. That's what happens when I rush. And then the cos over cos cancels, and I'm left with 1 over sine, which we know is cosec. Okay? I would highly recommend in writing equals cosec equals right-hand side, therefore proved. However, I was rushing with this. Then, part B. Yeah, so so 2 sine squared cos x minus 2 sine squared cos x. They cancelled, and then I was left with cos on my numerator, which is how I cancelled those out. Perfect. Then, it's asked us to solve it, so I've got 7 plus. Now, what's the difference with this and this? Yeah, so cosec instead of 2x, instead of x, sorry, it's now 2 theta. Because here we had cos x, here we've got cos 2 theta. So that's what's changed. So 7 plus cosec 2 theta equals 3 cot squared theta. Now there's 2 different ways to do this. However, I decided that cot squared theta we know is cosec squared theta minus 1. Okay? So if you ever have a cot squared and then a cosec on its own, it's the same as like having a sine squared and a cos on its own. You know that you're going to have to use, you know, the rule. And then, this was really simple. I then obviously expanded, simplified, moved everything to the left-hand side. I have quadratic here, put it into my calculator, solved it. I got cosec 2 theta equals 2 and minus 5 over 3. We know cosec is 1 over sine, don't we? So I just put 1 over these,
and then this gave me sine. So 1 over 2 minus 3 over 5. Then it wants it between minus pi over 2 and pi over 2. However, we know that because we have 2 theta, we have to double our interval. Now it becomes between pi and negative pi. The first answer it gave me was 1 over 6 pi, which is here. So then I reflect it in this line, like we always do, and then I got this one. So between 0 and pi, I got 0 to here is 1 over 6 pi, and then when I got to here, I know this is pi minus the angle, 5 over 6 pi. Then, when I did sine 2 theta equals minus 3 over 5, I got negative 0.643. So that's this angle here. However, we reflect it in this line, right? So that reflects to this angle. And between 0 and negative pi, it crosses twice. So I should have 4 solutions to get 2 theta. And then, obviously, you divide everything by 2 to get the final solutions. Okay? Question 8. Now this one was really wordy. Take a moment to read the words. However, it told us loads of things. How it was worth 4 marks, I don't know. I thought this was really simple. They tell us what the gradient and y-intercept is. As we've seen on other ones, sometimes they give us a graph and we've got to work it out, don't we? All we literally need to do is log this. So log p equals log of a, b, t. We know if we multiply, that means we add them. And then we've got b to the power of t, so we bring that t down, don't we? Then, think of it like this. Your t is your x. So if you've got mx plus c, well, log b must be your m. If t is x, think of y equals mx plus c. So your m is your gradient, and then the number on its own is your plus c. Okay, you just have to imagine, how would this fit onto a straight line? So then you know that log of a is 0.68, log of b is 0.09. How are you going to do it? Remember, log, when we don't write a basis to the base, 10. So 10 to the power of, 10 to the power of, this is always the same. It doesn't matter if it's a linear model or an exponential model, we are always matching up how it looks. So y equals mx plus c. Your x is normally always t for time, okay? So whichever one's got your t for time, the one that's multiplied by it is always your gradient. So however the model looks, it might be slightly different. Maybe on a different model, it's your t that's your gradient, okay? Instead, and your log b is actually your x. It just depends, but just match them up. Okay. Then it asks you to write the equation, which you've done. Part B, it says in context of the model. This means you have to make it into context, okay? So it's the percentage of population who have access to the internet at the start of 2005. It was a really simple answer. And then part C says use the model to estimate at the start of 2015, which is 10 years later, so you just substitute in 10, round it to 2 significant figures. So very nice, easy, 7 marks. Okay, integration. Now, what I love about this is that, remember, if we have a function on the denominator, essentially, this has got a bracket, and this is to the power of 1. If we ever have something to the power of 1, we know we're going to have to assume a ln. So, assume y equals ln of the denominator, okay? Then when we differentiate this, we multiply by the differential of the bracket. This differentiated is 6x minus 2. So sorry, that should definitely be a 4. 6x minus 4. Because 3x squared differentiated is 6x minus 4x differentiated is minus 4. However, we've got 3x minus 2. You notice that this is double this. So what do we have to do to the original equation? We need to half it. So then I get a half ln of the modulus plus c. So that was actually quite nice and easy, and this is why it's only worth 2 marks. Same for the second one. Our denominator is to the power of 3. So we know there's no ln, okay? It's like if there's no power on the denominator, you're probably going to have ln because it means it's to the power of 1. So then what do we assume? Well, what would differentiate to give me a negative 3 if it was negative 2, wouldn't it? So I'm going to assume this. So bring the power down, decrease the power by 1. I then need to multiply by the differential of this bracket, which is e to the 2x minus 1 differentiates to e to the 2x. Now don't forget, e to the 2x, that means that that bracket is also 2x, doesn't it? So then I have to multiply by the differential of that bracket, which is in fact 2.
that gives me minus 4e to the 2x, e to the 2x minus 1, all to the power of minus 3. However, you can see we don't have minus 4 lots here, do we? We just have 1. So I need to divide by negative a quarter and plus c, okay, to get back to that. Nice and simple? Okay, so question 10. Now, here are all the work solutions which I'm going to take you from. Okay, so this was the last question, right? So, the beginning part, just a heads up. If it ever says in the question, x equals something, now, it will either give you a sec squared, a sine squared, a cos squared, a tan squared, even a cot squared or a cosec squared. Why? Because there will then always be, if there's ever a find dy by dx or dx dy, there will always be then the square root of something. And the only way to do that is, you know, like sine squared plus cos squared equals 1, or how we do it, okay? So if you ever see a question like this, you know you've got to do some rearrangement. Okay, so we're going to go through this question and look at some of the tips and tricks. So, first of all, it wants us to find dx by dy. Now, remember, sec of something squared, sec squared of 2y can be rewritten as this. Okay, so, how did I get 6? You bring the power down. 2 times 3 is 6 times, obviously, the rest of the bracket. Then you multiply this by the differential of the bracket. Sec 2y differentiated is sec 2y tan 2y. We're given this in the formula sheet. And then, don't forget, we have a 2y. So we then need to multiply this again by the differential of this tiny bracket, don't we? Remember, that's a bracket, even though we don't write it sometimes, okay? Which then we multiply by 2, and that's how we get 12 sec squared 2y tan 2y. Okay, so that's a nice and easy, and can you notice only 2 marks? Now, the next one is 3 marks, and honestly, I really don't think I think it's worth more than 3. They weren't very nice. So, I wrote dy by dx, okay? Now, whenever we then have to rearrange to put x's in, I know straight away I need to use what I got. They told us in the question that x equals 3 sec squared 2y. So that means x over 3 equals sec squared 2y. So every time I see a sec squared 2y, what am I going to substitute in? X over 3. This is pure substitution here. This is all you have to do. Always on these types of questions, this is the same scenario. Maybe you have different trig functions, okay? So what's going to happen is we substitute in. Now, x equals 3 sec squared 2y. What I did is I took out 4, okay? And I know that 3 sec squared 2y was x, so that's where I substituted x here. Then I was left with 3 tan 2y. Now, I know the relationship, whenever we're dealing with these questions, there's always a 1 involved, okay? So it's either, you know, sine squared plus cos squared equals 1, or tan squared equals sec squared minus 1, however it is. Okay, now these x's, by the way, are not the same as like x. I've just used, this is like, they could be thetas. This is just the formula that I'm rearranging. So I rearrange this, and sec squared 2x, once we rearrange it, I know that that's x over 3 from the original question. I then substitute that in, okay? So then I have 1 over 4x root x over 3 minus 1. Okay? I'm now thinking to myself, right? What do I do now? Okay? Because in the question they want root 3 on top, don't they? If we have a look at the question, they want a square root of 3 on the numerator. However, do you know what I just realised as well? 3 tan 2y. I think there should be a 3 here as well, shouldn't there? Oh, yeah. Sorry, guys. If I just take 4, yeah, that's right. That needs to go. That needs to go. My error. Okay. Yeah, because 4 times 3 times 3 is not 12, is it? Right, so then I know it's root 3. Now, if I have to multiply this by something, I can only multiply it by 1. So I multiply it by root 3 over 3. You're probably saying now, how did I get this? So I didn't write this down because I wanted to break it down for you. So 4x root 3 root x over 3 minus 1.
Now, remember that root 5 times 4 is the same as root 20, is the same as the square root of 5 times the square root of 4. That's exactly what I'm going to do. I'm going to get 4x square root 3 lots of x over 3 minus 1. I then multiplied 3x over 3, I've got x, and then 3 times minus 1 gives me minus 3. Okay, so I've just done that in one step. So that is how we get the second part of the question. Now, the third part. Now, this was really bitty because it wants m and c as exact rational numbers. Okay, rational means we cannot have a surd on the denominator. Okay, so we know that y equals pi over 12. So x equals, now we know that x equals 3 sec squared 2y, which can be written as 3 over cos x squared. Okay, so here, this 2y is 2 lots of pi over 12. When I put that into my calculator, I got a really lovely number, 4. Fantastic, couldn't have asked for a better number. Okay, and then dy by dx. Now that I know my x is 4, and I have this, I substituted in x equals 4 to get root 3 over 16. So, if this is my gradient of my tangent, my gradient of the normal is the negative reciprocal. I then have my y-coordinate, my x-coordinate, my gradient, y equals mx plus c is here. Okay? Then, what does c equal? Well, obviously pi over 12 plus 16 over root 3 times 4, which is here. Pi over 12 plus 64, that was really easy. And it wants it all exact, so there was no putting it in the calculator. And then I read it wants rational. So then I had to multiply this by root 3 over 3 to get 16 root 3 over 3, and I had to multiply this by root 3 over 3. I didn't write that in there. Okay, but that is how I made them rational. So you wouldn't have got the last mark if you didn't do that.